Students are losing points every single semester because they continue to mix up accuracy and precision. But honestly, it's one of the easiest fixes you can make in your entire STEM journey, because once someone explains this clearly, it's actually shockingly simple. And today, I want you to walk away with a powerful, confidence-boosting understanding of what these two ideas really are. So by the end of this video, you're going to learn 4 things. Number 1, you're going to learn what precision really means. Number 2, you're going to learn what accuracy really means. Number 3, we're going to cover the 4 classic cases that almost certainly stump every student. And at number 4, we're going to summarize with the one rule that makes this whole concept click. This is going to be foundational knowledge, and the clarity that you get today is going to pay off in just about every physics, chemistry, and engineering class that you take from here on out. So if at any moment something clicks for you or you get that aha feeling, I want you to drop a comment with what finally made sense to you. Your insight that you share could be the one thing that someone else needs to finally understand this subject as well. And that's what the channel is all about, sharing what we know so that we as a collective can understand science better. So let's dive in. First up is precision. And when you think about the word precision, I want you to correlate this to consistency. And this is a really powerful idea once you understand it. So let's work on an example. So if you had a scale and you were weighing a 10-kilogram block and you got the following 3 measurements, you would say that these measurements are precise. And we say they're precise because they are consistently getting you to the same value. And if you measure something over and over and over again and your numbers are tightly packed together, that is high precision. It means that your method is repeatable, stable, and under control. So precision simply answers the question, how tightly grouped are my results? And number 2, let's cover accuracy. And when you hear the word accuracy, I want you to think about the truth. I want you to think about how correct something actually is. So precision is about agreement and accuracy is about truth. So let's use the same example. Again, we have our scale weighing our 10-kilogram block. This time, however, our measurements are actually close to the true value of the block. Therefore, we would say that these measurements are accurate. Now, when we put these 2 ideas together, we unlock something that's incredibly insightful. So let's take this one level deeper by going over the 4 classic cases that stump just about almost everyone. So what I've drawn here are 4 sections. Section number 1, high precision, high accuracy. Section number 2, high precision, but low accuracy. And section number 3 is going to be low precision, but high accuracy. And lastly, low precision and low accuracy. So let's quickly go over what each of these actually looks like. So number 1, let's say we had a dartboard and we want this to both be highly precise and highly accurate. That means these numbers are going to be grouped up together and they're going to be pretty close to hitting the center. Case number 2, high precision but low accuracy. This means the numbers are consistently grouped together, but they're missing the target. Case number 3, low precision but high accuracy. This means that on average, our measurements are going to get us pretty close to the target, but they're not going to be tightly grouped up. Case number 4, low precision and low accuracy. You might as well be Usopp from One Piece and be shooting ketchup stars wherever you feel like it at random. These measurements are neither grouped tightly nor close to the center. But that's not all. I want to go ahead and give you even more value so that you feel comfortable working with this in your actual laboratory experiments. So our first example is going to be miscalibrated equipment. And you're going to be able to recognize this because your measurements are going to be off from your desired value by a fixed amount. This is high precision but low accuracy, and it's a classic case of what we call systematic error. And being able to recognize this is a pro-level insight. For our second example, we're going to cover reaction time. And the classic case is measuring the time it takes a car to travel a certain distance, which can yield the following 3 measurements. And as you can see, they're not too closely grouped together, but not too far apart. And this is a classic example of random error. In this case, your measurements aren't off by a fixed amount like they are in systematic error, which makes these types of errors greatly unpredictable. So once you know both these 2 types of errors, your lab reports are going to become so much easier to interpret. As promised, let's go over the one rule that's going to make this all click. If you remember nothing else from this video, I simply want you to take away that accuracy is closeness to truth and precision is closeness to each other. If you know this level of clarity is going to be what boosts your grade, strengthens your intuition, and makes you feel more confident in every single lab report. So if you found this video powerful, insightful, or genuinely just valuable, drop a comment sharing what you learned so that someone else can learn from you. Because that's what this channel is all about, us sharing our information so that we as a whole can get better.